I've just bought this McLaren 600 LT and it was so cheap, I just couldn't say no. I received a message saying that their friend has crashed a McLaren and was looking to sell it. And just from looking at the photos, the damage doesn't look too bad.
Imagine buying a McLaren without ever seeing it in person, knowing it has already been crashed, and then giving yourself only 7 days to bring it back to life. That sounds less like a smart car purchase and more like a terrible decision waiting to happen. But that is exactly what happened with this McLaren 600 LT. At first glance, the deal looked almost too good to ignore. A message came through saying that someone had crashed a McLaren and wanted to sell it. Photos were sent over, and from those pictures, the damage did not seem completely out of control. There was damage, obviously, but nothing that immediately made the car look impossible to repair. The problem was that the car was not sitting in a workshop down the road. It was all the way in Greece. That meant there was no easy way to walk around it, open the doors, look underneath it, or properly inspect the mechanical parts before making the decision. The only thing available was a set of photos and a choice: walk away from the deal or take the risk. The price was good enough to make that risk tempting, so the decision was made. The McLaren was bought without seeing it in person. That one decision would soon become the biggest question hanging over the entire rebuild. Was the car actually as good as it looked in those photos, or had the pictures hidden the worst of the damage? After the purchase, the car had to make a long journey from Greece back to the UK. It was loaded onto a trailer and transported all the way home, but even after the journey was finished, there was no way to know exactly what had been bought until the car was finally inside the workshop and the damaged parts started coming off. When the McLaren arrived, the excitement was mixed with a lot of uncertainty. The goal was no longer simply to repair a crashed supercar. There was now a deadline. The date was Wednesday, July 29th, and the plan was to have the entire car rebuilt by the following Wednesday. That gave the team only 7 days. 7 days to find every damaged part, work out what could be repaired, order replacements, remove broken components, rebuild the car, and hopefully get it back on the road. The first job was therefore obvious: get the McLaren inside and start taking it apart. There was no point guessing from the outside anymore. They needed to know exactly what they were dealing with. The 600 LT itself made the challenge even more interesting. This was not a heavy, simple sports car that could be repaired with cheap parts. The car was built around saving weight wherever possible. It weighed around 1.3 tons and produced nearly 600 horsepower in standard form. It used lightweight components, carbon fiber body panels, carbon bucket seats, a shorter exhaust system, and lighter suspension parts. That made the car exciting to drive, but it also meant that an accident could become very expensive very quickly. A small-looking piece of damage could turn into a huge repair bill if the damaged part was made from carbon fiber. And that was exactly what the team was about to discover. Before worrying about the bodywork, suspension, or interior, there was one question that needed an answer: would the McLaren even start? If the engine was damaged, the entire project could change immediately. So the first real test began with the battery. The original McLaren lithium-ion battery was completely flat, and replacing one was not cheap. Even a used battery could cost more than £2,500. The team decided to try saving the original battery instead. To reach it, they had to remove the tub covering it, which was already damaged in the crash. Once the battery was accessible, the next problem appeared: the pyro fuse. This safety device is designed to cut power during a serious accident, helping prevent electrical problems and reducing the chance of the engine being restarted when the car may not be safe. The team suspected it had blown because the driver's side airbag had also deployed. They checked the fuse for continuity, and there was no beep. That meant the connection was broken. The McLaren had another problem before it had even started. But there was also a possible solution. Instead of paying a huge amount for a complete fuse box from the manufacturer, they removed the damaged fuse, checked its part number, and discovered that the same type was used on other cars. A replacement could be found for around £13.15. Suddenly, what could have been a very expensive problem looked much easier to solve. The new fuse was ordered, the battery went on to charge, and the team waited. But they did not want to waste an entire day doing nothing. They wanted to know whether the engine itself was alive. So they created a temporary way to give the starter motor power. The car had a broken radiator, meaning they could not safely run the engine for long, but they only needed a few seconds to answer the most important question. They pressed the start button, and after all the uncertainty, the McLaren came alive. The engine started. It sounded smooth. The car was not dead. That was the first major victory of the rebuild, but it was also only the beginning. The engine running meant the project was still alive. Now they had to find out just how badly the rest of the car had been damaged, and with only 7 days left, every discovery mattered. The engine starting was a huge relief, but it did not mean the McLaren was healthy. In fact, it only meant that one of the biggest questions had been answered. The real work was about to begin. The team now had to remove the damaged parts one by one and find out what had happened in the crash. When a car like a McLaren 600 LT is damaged, the outside can sometimes hide problems underneath. A panel may look reparable while the suspension behind it is bent. A wheel may look damaged while the force from the impact has traveled into the hub, control arms, or even deeper into the structure of the car. That was why the team could not simply replace the parts that looked broken and hope for the best. They needed to strip the car down and inspect everything properly. The first major area was the front bumper. At first, there was some good news. Parts of the bumper appeared to be damaged but possibly reparable. This was important because the McLaren used many carbon fiber parts, and replacing those parts through the manufacturer could become extremely expensive. The bumper was also made from several separate pieces rather than one huge part. That actually worked in the team's favor. If only one section was damaged, they could potentially replace or repair that small section instead of buying the entire bumper. The headlights were removed so the bumper could come away, and thankfully both headlights looked okay. That was another small victory because damaged supercar headlights can be very expensive. The lower splitter had some damage, but the team believed a body shop could repair it. Instead of throwing away every scratched or cracked part, they were trying to save as much as possible. Every repair saved money, and every pound saved mattered because the 7-day deadline was already running. Then they looked underneath the car and found another expensive problem. The undertray was badly damaged. The surprising part was not only that it was made from carbon fiber, but that a second-hand replacement could cost around £4,000. For a piece that sits so close to the ground and can easily be damaged by an accident or road debris, that price was shocking. The team decided that replacing it was not the first choice. They would send it to their carbon specialist and see if it could be repaired instead. This was becoming the main strategy of the rebuild. Repair what could be repaired, replace only what absolutely had to be replaced, and keep the project moving. The damaged bumper pieces were also sent to the body shop. Some had small scratches and scuffs, while another section had broken tabs that might be glued back into place. If the body shop could restore those pieces during the week, the team would save both money and valuable time. But the front end was not the only concern. There was still a damaged front wing, a deployed airbag, and a door that had clearly taken a serious hit. The front left wing turned out to be beyond repair, but there was at least one advantage. It was made from aluminum rather than carbon fiber. That meant replacing it would be much cheaper than replacing one of the car's carbon panels. The door was a different story. It was badly damaged, and the team needed to remove the door card and inspect the airbag system. They also suspected that the seat belts could have been affected by the crash. In a serious accident, the seat belt pretensioners can activate along with the airbags. Even if the belts still appear to work normally, the car's computer can record a fault that prevents the safety system from being considered fully repaired. That meant the team could not simply look at the belts and decide they were fine. They needed to scan the car and find out what the electronics were saying. Before doing that, they removed the damaged door card. It had been opened by the airbag during the crash, and there was a tear in the material. At first, this looked like another expensive replacement. A brand new McLaren door card could be costly, and waiting for the correct replacement could also destroy the 7-day plan. Fortunately, the team had another option. The damaged door card could be sent to an airbag specialist, where the Alcantara could be repaired and stitched back to the original standard. The airbag itself also appeared to be reparable because it did not have holes in it. The plan was to have the specialist reset the system so the original parts could potentially be used again. This was another example of how the team was trying to save time and money instead of automatically replacing everything. But there was still one question that could change the entire interior repair: the seatbelts. If they were faulty, Removing them would mean taking apart much more of the interior. That would add more work, more parts, and more time. At this point, the team had already removed the damaged door card and airbag, but they were hoping the seatbelts would turn out to be okay. They connected the battery and scanned the McLaren for fault codes. There were plenty of faults stored in the car because of the crash, but the important ones were related to the seatbelt pretensioners. The scan showed that both the driver and passenger pretensioners had faults, along with a recorded driver-side crash. That confirmed the bad news. The seatbelts had to come out. The 7-day rebuild had just become harder. These were not ordinary seatbelts that could simply be cleaned and bolted back in. They contained explosive devices designed to activate during a crash and pull the occupants tightly into position when the airbags deploy. Because the system had recorded the accident, leaving the belts untouched would keep the airbag warning light on. That would prevent the car from being considered properly repaired and could stop it from passing the UK's roadworthiness test. So the team had no choice. Both seatbelts had to be removed and sent away for repair and resetting. Getting them out was not simple either. They were positioned in a cage behind the seats, meaning the team had to remove the protective structure before the belts could be taken out. Once the top section was released, the lower part could be unbolted from the seat area. Eventually, both belts were removed. The damaged airbag, door card, and seat belts were now ready to go to the specialist. That was another major job completed, but the list of problems was growing instead of shrinking. The team still had to inspect the front suspension, radiator, and rear of the car. The radiator was the next obvious problem. A replacement wheel hub was found for around 495 pounds, and it shared a part number with components used on other McLaren models. More parts were ordered, but the rebuild was becoming a race against time. The team had started with the hope that the damage would be manageable. Now they had a long list of replacement and repair jobs, and they still had not fully inspected the rear of the car. That was where the biggest question remained. The rear wheel looked completely wrong, and the team could not understand how it had ended up in that position without causing even more damage. They knew something serious had happened around the rear suspension. They also had concerns about the subframe, the frame, and the gearbox. The drive shaft did not look healthy either. As they began taking the rear apart, the answer started to appear. The rear wheel was badly damaged. Another wheel had already been found in poor condition, and the lightweight McLaren wheels clearly had not survived the crash well. But the wheels were only the beginning. Once the arch lining was removed, the team could finally see behind the damaged bodywork. And what they found was not good news. Almost the entire rear suspension had been damaged, including the drive shaft. The car that had looked like a relatively simple repair from photographs was turning into something much more serious. The 7-day deadline was still running, the parts list was growing, and the biggest question of the rebuild had not been answered yet. How far had the crash gone into the car itself? The front of the McLaren had already given the team plenty of reasons to worry, but the rear of the car was where the rebuild could either become a manageable project or turn into a complete disaster. From the outside, the damage was confusing. The rear wheel was sitting in a position that clearly was not normal, yet there did not seem to be huge amounts of bodywork damage around it. That made the situation even more worrying, because when a wheel is pushed into such an unnatural position, the force has to go somewhere. It could have damaged the suspension, the hub, the drive shaft, the subframe, or something much more serious underneath the car. The team knew they had to stop guessing and start taking everything apart. The 7-day deadline was still running, and every hour mattered. They had already discovered the broken radiator, damaged front suspension, cracked carbon brake disc, damaged wheel, broken bodywork, faulty seatbelts, deployed airbag, and expensive carbon parts. Now they needed to know whether the rear of the McLaren had survived the impact. As the damaged parts started coming away, the story became clearer. The rear wheel had taken a huge amount of force, and the suspension around it had not escaped. The wheel itself looked completely destroyed, adding to the growing list of expensive parts that needed to be replaced. These lightweight McLaren wheels may help reduce weight and improve the driving experience, but after an accident, they can become another major cost. This was already the third wheel the team had seen in bad condition, which showed just how hard the car had been hit. But the wheel was not the biggest concern. Behind it was a much more serious problem. The rear suspension had been damaged badly, and the drive shaft was also broken. A drive shaft is not a part you want to find damaged on a car like this because it is directly connected to the system that transfers the engine's power to the wheels. The fact that it had been damaged meant the impact had gone far beyond a simple bodywork problem. The team had hoped that the crash might have been limited to replaceable suspension components, but now they had to consider whether the force had reached deeper into the car. They were particularly concerned about the subframe and the actual frame. If those areas had been damaged, the 7-day challenge could become almost impossible. A bent or damaged structural part would require much more than simply ordering a new suspension arm. It could mean specialist repair work, measurements, alignment checks, and potentially a much larger bill. The gearbox was another concern because the broken drive shaft could have transferred force into the drivetrain. At this point, the team could not simply assume the gearbox was fine. They needed to inspect everything carefully before moving forward. This is where the rebuild became much more than a collection of repairs. Every damaged component was connected to another question. If the wheel was broken, what caused it? If the suspension was bent, how far did the impact travel? If the drive shaft was broken, did the gearbox take any of the force? And if the rear suspension had moved far enough to damage several parts, was the main structure still straight? Those questions mattered because the entire project depended on the answer. A supercar can have thousands of pounds worth of damaged parts and still be reparable if the main structure is healthy. But if the structure itself is bent, the entire calculation changes. The team continued stripping the rear area, removing the arch lining to see behind the bodywork. This was one of those moments where the viewer could feel the tension because every panel that came off had the potential to reveal something worse. The photographs from Greece had made the damage look manageable, but now the car was sitting in a workshop with its bodywork removed, and the reality was becoming impossible to hide. The rear suspension was not simply scratched or slightly bent. It was broken. The drive shaft was also completely damaged. This discovery was important because it proved just how misleading an accident can be when viewed from a few photographs. The outside of a car can hide the force that has traveled through its mechanical parts. What looked like a damaged wheel from a distance was actually part of a much larger chain of failures. The impact had affected several pieces at once. For the team, this meant the parts order had to grow again. More suspension components would need to be sourced, another wheel would need to be replaced, and the drive shaft would need attention. The project was becoming a race, not only against the clock, but also against parts availability. Finding a part is one thing. Finding it quickly enough to arrive during a 7-day rebuild is another. A part could be available. The project was becoming a race, not only against the clock, but also against parts availability. Finding a part is one thing. Finding it quickly enough to arrive during a 7-day rebuild is another. A part could be available somewhere, but if it took a week to arrive, it was almost useless for this challenge. That was why the team had to balance new parts, used parts, repair work, and specialist services. They were constantly asking the same question: can we repair this? Can we source it quickly, and can we afford it? The carbon fiber components created another layer of difficulty. These parts were designed to be light and strong, but when damaged, they were expensive. Throwing away every carbon piece would quickly destroy the budget. Repairing them required specialists who knew how to work with carbon fiber properly. That meant some parts could leave the workshop and go to specialists while the team continued working on other areas of the car. This was essential because waiting for one repair would waste valuable hours. The rebuild had to happen on several fronts at the same time. While the bodywork was being repaired, the airbag team could work on the safety components. While replacement suspension parts were being ordered, the workshop could continue stripping the car. While the radiator was being replaced, the team could inspect the rear. Every job had to move forward wherever possible. That was the only realistic way to have any chance of finishing within 7 days. The more they removed, the more the original crash began to make sense. The car appeared to have hit something hard enough to push the suspension backward and damage multiple wheels and mechanical components. The team even joked about how the wheels had ended up in such strange positions, but underneath the humor was a serious concern. They were trying to understand the path of the impact. When a car crashes, the damage often follows a pattern. The part that hits first takes the initial force, but that energy can then travel through connected components. A wheel can be pushed backward into suspension arms. Suspension arms can transfer force into the subframe. The hub can pass force into the drive shaft and drivetrain. That is why simply replacing the most obvious broken part is never enough on a serious crash-damaged car. Everything around it has to be checked. The McLaren was now becoming a perfect example of that problem. The original photos had not shown the complete story, and the workshop inspection was revealing damage that could not have been understood from a screen. This was the risk the team accepted when they bought the car sight unseen. They had taken a gamble because the price looked good, but now they were paying for that gamble in time, stress, and an increasingly long parts list. Still, there was one thing working in their favor. The main engine had started and sounded healthy. That gave them a reason to keep going. If the engine had been damaged, the project could have ended almost immediately. Instead, the heart of the car appeared to be alive. The challenge was now to rebuild everything around it. The team had to repair the body, restore the safety systems, replace the suspension, repair or replace the carbon components, fix the cooling.